Hello everyone, welcome to another AP Computer Science video. We're continuing with our topic of inheritance in Java. And if you don't remember from the last video, the idea of inheritance is one where we connect classes in a relationship that allows us to minimize how much code we write. And so the relationship is what we call an is-a relationship. One class is of another class's type. And essentially this allows us to pass along instance variable data as well as functionality, methods and functions in classes. And this is a very powerful tool. It allows us to minimize how much we write, and if we plan our classes in a smart way, we can expand them, make them flexible without too much extra work. And so we're going to continue with that example today. Just a quick review of the diagram that we were talking about. We had said that all classes inherit from object whether we knew it or not, and now we're kind of seeing the facts as they come along. It was always the case. Strings were objects, scanners were objects, array lists were objects, persons were objects. Person is a class that we made, and then we were going to plan out a sub-hierarchy of students that are persons, teachers that are persons, and grade leads that are teachers. And so far we've made the person, and automatically the default was that its parent was object. And so we're going to move on today and we're going to construct these teacher and student classes and change the default behavior. So we're going to change the fact that student's default parent would be object, but it's going to become something different. So we'll see that in a moment. So we also saw in our test to just kind of prove a point that default constructors are created for us if we do not choose to create constructors. But typically we do, and therefore we should always have a default, and maybe if we need one, a non-default constructor. We also mentioned last time that the first thing that's done, whether we see it or not, is that the parent constructor is called, and we talked about how here it is implicit that the parent is called. We don't see it, and today we'll prove this by creating explicit calls to parent constructors, and then we can verify that implicit also exists. So here we go. We're going to make a new class in our inheritance package, and it's going to represent the student. So there's my class student, and by default, public class student is a student class. Its parent, whether we see it or not, is the object class, but we want to change that behavior. And so what we're going to do is a new keyword, the extend keyword, extend, that allows us to say, actually, your parent is this other class. So here we go. We're going to say extends person. So a person is a class that exists, and a student is now a person. The is-a relationship is one direction. A student is a person, and that extends that one direction. This implies the first benefit: we gain access to instance variables that exist in the person class. We gain access to methods that exist in the person class. And so that means, so far, we've only really gained two instance variables and then the constructors of the parent, and we're going to come back and add more here in a little bit. But really the benefit is that we can inherit that information. So we said, again, when you design a class, what we're trying to imply is that a student is more than just the thing it inherits from. So it is a person, it has a name and an age, but students also have, we'll say, a GPA and a grade level. So students are persons, but with more information. So we're going to go ahead and make our own instance variable in this class, private, and we'll say double GPA, and we'll say private int grade level. And so that tells us those things. And so now they are private just like always. And so now let's make a constructor. And I'm going to go ahead and set up a constructor for our student, a default public student. And I'm going to prove a point now. So this constructor is built. It doesn't do anything meaningful, but it does exist, a default constructor. And I said that parent constructors are either called explicitly or implicitly first. So I'm going to go ahead and put that note here. Parent constructors must be called first, implicitly, or explicitly. And so right now, whether we see it or not, the implicit call is the one that's happening. So whether we know it or not, it is happening there, and we can prove this pretty easily. If I go to the person class, there's the default. I said that because I made a non-default, if I didn't make a default, it wouldn't exist, and I'm going to temporarily hide it. So I'm going to save it with this commented out. So there is a constructor, but it's a non-default, and I'm going to go to the student, and we're going to see that there's a problem that's going to occur. There's an error, there's the red error. I don't know why it's not popping up just yet. It should show up. Let me close and reopen it. But there is definitely an error in student. I don't know why it doesn't try not to. Let's say GPA equals 4.0. There you go. So now, so the error should be there. I don't know why it's not popping up. Let's get here. That's another error. There, that one goes. I wonder why this is not happening. Let's try this. And so let's go ahead and get rid of that and say, I'm actually kind of surprised that it's not showing the error. So give me 1 second. I'm going to check to make sure there's not something wrong with NetBeans. Okay, I'm not sure why NetBeans is choosing not to show the error directly on my code, but I did compile it and we can see this error here. And it's not an obvious one, but I do want to make it clear. It says, error constructor person in class person cannot be applied to given types. Required string and int, arguments none. In fact, in this student class, there is no person constructor being called seemingly, but in fact there is one. Whether we see it or not, behind the scenes it says, well, you're a default constructor, you must call a parent constructor. The default is the most reasonable one to call, and it fails to do so because it does not exist. And this is why this error occurs, because I commented this out, it no longer exists. And so it says, well, that doesn't work out. So I have two choices. I can fix this and make sure that I have a default, either by erasing this one so that no constructors exist and therefore one is made for us, or I can bring this one back. That's another choice, and that's what I'm going to do. But there is a third choice, and that is to call the non-default. Right? So implicitly means that it's done for you. Explicitly, we can do this by using the super keyword. This is going to be the first instance where we see the super keyword. So I'm going to put a note. We can call parent constructors using the super keyword. Right? And so the way we do this is the super keyword is also given a set of parentheses, and these are the inputs to the constructor. So it recognizes when you say super, it means parent class. Very much like this, the keyword this means this class, the class that you're writing in. And so in this example, to fix this, the third solution is to call the non-default that accepts a string and an age. And I might say, you know what? A default student is named just like we'll say, well, the default name is Jane Doe. I'll say my default student is called Jimbo Jones, and they have an age of 15. And now if I save this and give it a moment, we should see that the error on student has gone away. Now this one's still there because there is no default to call. That's fine. But in student, suddenly it's not complaining anymore. And the key is that a parent constructor must be called, whether implicitly, behind the scenes, or explicitly. And so now there's another option, is to do this. Let's put this default back into our code. And then now instead of doing this, I could just call super. And notice there is no error anywhere now, because now this is an explicit call to the default constructor. It says, okay, go to your parent class and match a constructor that accepts no parameters. And then it's going to search and go, oh, there it is. And then that means our student would be named Jane Doe and be age 15. Right? But this is what happens behind the scenes if you don't do it anyway. So by just getting rid of it, it's as if it's still there. We just don't see it. One last thing I'll do to point out, and I mentioned that it must be called first, is to try this. If I did super. It's explicit, but if I read the error it gives me, it says call to super must be the first statement. So if you're going to do it explicitly, it must be done first. If you don't do it at all, it's done implicitly, and it's done first whether we see it or not. It's always like crammed at the top of our constructor. There is no rule that says a default must call a default. There's no rule that says a non-default must call non-defaults. Any constructor from a class can call any parent constructor, whatever you are comfortable with. And of course, if we let the defaults, the implicits happen, then that's fine too. And we can always change these things. So I'm going to go ahead and we'll leave this one implicit, whether we know it or not. So I'm just going to put a note here. The parent constructor. So there it is, whether we see it or not. And then, of course, we need to fill in our GPA and our grade level. So we'll say, since we assume the age is 15 and we assume the GPA is 4.0 because they're starting high school, then we can say, let's assume that their grade level is 9th grade. And there it is, right? And then if I ask you how many instance variables have been initialized, the answer is now 4. The GPA explicitly by us, the grade level by us, and then because that default constructor is called behind the scenes, the name is given to Jane Doe, the age is given to 15. And so this is good. Let's make a non-default constructor. and try using the non-default of the parent. So we're going to say public student. And we'll say, you know what? If you create a student without a default with parameters, we'll accept the name of the student. So I'll say string name. I'll say the int age. And I'll say the grade level. So we'll say int grade. And there we go. And then now here's the problem. The grade one is easy. I can say grade level is equal to whatever the grade is. Now we have some choices here. And actually we think we have choices, but we're actually quite limited in what's happening. The first is that, okay, well, since we are, and this is where it's kind of not a perfect approximation. The analogy we've been using is still not really great. I said a student is a person, and therefore they have access to a name and an age, but in reality, in the technical aspect, we do not have direct access to the name and age variables because the parent class made them private. So we're kind of trapped here. We say, okay, well, I have my own name and age, but I can't even look at them because they're not really mine. They're kind of in my parent version, and so I'm not in charge of them. So let's make the attempt. If I said, I should probably rename these just so we don't confuse them. So this is called name and age. Let's call this one NM again. We'll call this one AG. And so it's perfectly, it would be reasonable to say something like name equals NM, just like we did in the parent, and age equals AG. But if we read the error that it gives us, name has private access. It says, look, you may be a person, and you may have these variables, but you don't have the right to even look at your own variables because they're, technically speaking, your parents' versions that you just happen to get a copy of, and you don't have a right to look at them. And so we have to either call a parent constructor, or maybe make public accessors and mutators, and that's not unreasonable, though typically speaking in a constructor you want to call constructor. So the solution would be to say, you know what, if we want to call the parent stuff, let's fill them in. Let's say super nm ag, because this call, and I can prove it by actually using NetBeans. If I use the control key and I hover over the super keyword, it'll take me to the it even shows it there. It says inheritance.person, that this super is referring to person string nm int age. It recognizes that this is the constructor you're calling to. When I click on it, it'll even jump into that code. It says, hey, the super reference is actually to this constructor, so it matches perfectly. And again, one more kind of proof of concept. If I try to do this after the fact, it'll be an error. It must be the first thing done. Right, so we can say, we can call non-default. So at the end of the day, we've still initialized 4 different values. And then, of course, since I didn't do it here, the grade level, let's assume the GPA is 4.0. So GPA is equal to 4.0. So all 4 instance variables have been filled in. Here, they've been, the 2 internal ones have been done implicitly. Here, I've done it explicitly. I've passed along my data to my parent's constructor, so all 4 variables were filled. Let's go ahead and, again, we could add more, but I'm going to stop here and let's move to another class. Let's make it to a teacher, because the teacher's a little more complicated, and then we'll keep going. So let's make a new class, and we'll call it teacher. And so again, instead of leaving the default parent of object, we're going to use the extends keyword, and we're going to say that a teacher is a person. That means teachers have names and ages. But now I'm going to say teachers also have some other instance variables. We'll say teachers have, we'll call it the department that they're in. So we'll say string, which department? Are they part of the math department? Are they part of the English department? Are they part of the science department? And so on. So we'll call it department. And then we'll say that teachers also have a list of students that are part of their advisory or homeroom or whatever you want to call it. I'm going to call it advisory. And of course now it gives me an error for the array list, so I need to fix imports and import the array list class, and there it is. Now again, this relationship is not inheritance. This is the composition relationship. A teacher is composed of or connections to students, but a teacher is a person. And now let's go ahead and make a default constructor. So we'll say public teacher. I'm going to say, again, I can use the default parent, which would be the person. So that means our teacher's name is going to be Jane Doe, and she's going to be age 15, which is not a good choice for a teacher. So we need to fix that, and that's something we have to deal with. And then we can at least set up our department. We'll say, you know what? And this is maybe my bias, but I'll say, if you don't tell us the department you're in, you are part of the mathematics department. Right? And we'll say, and computer science. because that's a nice department name. And so there's our mathematics and computer science department, and that's the default department. And then now we have to initialize our list. Remember, an array list reference is just a null reference until it's constructed. So let's fill up our advisory, or at least make the list, and we'll say it's a new array list of student objects. Now, that doesn't mean there are students. There's still no students in my advisory, but that's okay. And we could fill them in maybe with a method. We'll do that in a little bit. And so now this is fine, but the age is still a problem. The default implicit parent constructor of person assigned 15. Teacher should not start at 15. We could say, I would say realistically, the youngest you might find a teacher that's finally teaching is 22, maybe 23, depending on how many years they were in college. So we'll just say 22 is the youngest, because that's 4 years of college after 18. It's just an arbitrary number. How do we set the age? We could call the non-default constructor. That lets us set the age, but it also makes us set a name, and I don't want to change the name. I want to maybe just change the age. So what I'm going to do is let's go back to our person class and let's make some constructors. We still have the limitation of I can't even access or change the individual variables if I wanted to. If we wanted to call make a method in our subclasses called age up or birthday, we couldn't do it because it wouldn't have direct access to these variables. So we're going to make accessors and mutators. So let's quickly make some accessors and mutators. Public string get name, return name, and then let's do public int get age, return age, and then let's go ahead and do mutators. We'll say public void set name, string nm, name is equal to the name, public void set age, and we'll say the age equal to whatever they told us. Right, so there they are. They are public, therefore these are accessible. The reason that these were not accessible is because they're private, and that's the behavior that Java wants us to use. Right? We always make them private, and therefore, yes, it's a little bit of a burden, but we must make accessors and mutators, even for inheriting classes. So now I can safely say, you know what? Let's assume your department is mathematics and computer science. Let's assume you have no advisory, and let's go ahead and assume your age is 22. So now I'm going to say, and now here's the thing, I have 3 ways of calling the same method, and in this situation they all mean the same thing, and we'll see in a little bit that in a different situation they do have very specific meanings that might differ depending on what we're trying to do. But I'll say the first way we can do it, we can call inherited methods in 3 ways. One, with this keyword, right? So here we'll say this dot set age to 22. No problem, no errors. And again, this makes sense because again, if a teacher is a person, they have inherited the set age mutator and therefore have access to it as if they were their own. So this is my method, the teacher's method. So this dot set age. So the equivalent of this would be just using the method name. This is implicit, right? That this keyword is implicit. So I could also say set age. These two are equivalent. So if I commented this one out, there's no difference. Because again, if you don't put a object reference something dot, the assumption is it's the object that you are, which is in the class. So a teacher object is calling this method. This teacher object, right? It's implicit. So you can do either one of these are equivalent, and that's fine. And the third version is using the super keyword and dot notation. And this is the one that might differ depending on the context, and I'm going to go ahead and put the note here, the parent version. This is the parent version. So I could say super dot set age 22. Oops. And there it is. And so this version is the same as these three. The difference in this scenario, there isn't one. They're all the same. But when you say super dot, you're typically calling the parent's version, except so far, the parent's version and the child's version are the same. The teacher version of set age, which there isn't one, not really, it's inherited, is the same as the one that was inherited, which is the super dot set age version. They're equivalent. We will see one of the key advantages of inheritance is the ability to redefine methods. We're going to call this overriding, and we'll see this in the next video, overriding methods. And this gives us the ability to expand a functionality in a child or subclass without affecting the parent. And then the child version can use the parent versions, which may seem odd, but can really minimize the amount of code we have to write. And so we'll see this soon in our example. But I'm going to say my preference in this scenario, let me go ahead and do it at the front, is the first one. So I'm saying our department, or just to be consistent, but I'm just going to say, yeah, we assign a department, we assign our advisory, and we set our age to 22. That's the default. And then now let's do a non-default constructor. So okay, for the teacher, you tell us the name of the teacher, you give us the age of the teacher, you give us the department that they're in, and you give us well, that's it. That's all we really need. And we'll assume that their advisory is empty. So here we go, and we'll say, and now again, to pass this data along, I'm just going to use the non-default parent constructor, super name and age, because that's basically like calling this and the other mutator, but we're going to do it in one shot. And then we're going to set our department. So department is to whatever they told us. We're not going to assume anything. And we'll assume our advisory is an empty list again. So we can do the same thing here. A new array list of student objects. So far we haven't seen too much. Not really that exciting, but we want to just be aware of these different kind of technical details about inheritance and how methods. And so far we've seen a super keyword used for constructors, default and none, and the fact that because inherited variables are typically private, we have no choice but to use public accessors and mutators in order to change them individually if that's what we aim to do. So I'm going to stop the video here, and we'll continue next time expanding this example further. We still need to do another class, and then we'll see some of the real power in the inheritance, and this will be the ability to override methods and the ability to use what's called polymorphism to generalize our top-level code. That'll be our next video. I'll see you in the next video.